Hello, my name is Sally Cox-Morton. I am a Senior Biomedical Scientist in the Specialist Haemostasis Laboratory at Adam Brooks Hospital in Cambridge. Today I am going to take you through our process of performing a Bethesda assay, which is used to quantify inhibitors against coagulation factors such as Factor VIII. As this is a manual method, there may be slight interlaboratory variations, but the principles of the assay will be the same. First, we begin by heat treating part of our sample at 56 degrees Celsius, ideally for an hour, but for a minimum of 30 minutes. This denatures all of our coagulation factors whilst leaving our inhibitor intact. This step is important as it ensures there is no residual factor VIII in the patient plasma, and therefore the only factor VIII present is from the addition of the normal pool plasma. This results in an increased sensitivity of the assay, particularly when assessing patients for remission. Once we have heat treated our samples for an hour, we centrifuge at the same speed and time that we use for our normal routine haemostasis samples. Once centrifuged, we remove the supernatant from the sample into a separate tube to be used for testing for our Bethesda assay. It is important that we leave the protein pellet at the bottom of the tube undisturbed. Now we move on to labelling our tubes. We use the alphabet, with A being our neat patient sample, B is a 1 in 2 dilution of the patient's plasma, C a 1 in 4 dilution, and so on. For a first-time presentation, we set up a minimum of 10 tubes, which is up to a 1 in 512 dilution, although I have seen titers higher than this. If you have a patient with a known titer, we recommend doing 2 additional dilutions above their last result. For example, if the patient had a titer of 32 Bethesda units, set up dilutions up to and including a 1 in 128. We also need an extra label tube for our calibrator. We begin by serial diluting our patient plasma. First, we are going to add factor diluent or factor VIII deficient plasma if you are doing a Nijmegen modification to our patient tubes B through J, which is our 1 in 2 dilution through to our 1 in 512 dilution. Tube A, which is our neat, remains empty at this point. We add as a minimum 100 microlitres of factor diluent, but whatever volume you choose, ensure this is consistent throughout the procedure for your patient plasma and normal pool plasma. We are also going to add the same volume of factor diluent to our calibrator tube. Now we add our patient plasma. Keeping volumes consistent, 100 microlitres is added to tube A, which is our neat, and tube B, which is our 1 in 2 dilution. Tube B is mixed a few times using the pipette before transferring 100 microlitres from tube B to tube C, which is our 1 in 4 dilution. Again, tube C is mixed a few times using the pipette before transferring 100 microlitres from tube C to tube D. This process continues for the rest of the tubes, thus completing serial dilution. Once we get to our final tube, we discard 100 microlitres from it to ensure we keep a constant volume in all tubes. Alternatively, you can transfer this to a discard tube in case you have a very high titer inhibitor and need to continue the serial dilution process instead of starting from scratch. Finally, we add our normal pool plasma, which is our source of factor VIII, into all tubes including our calibrator. Again, keeping volumes consistent, we are adding 100 microlitres to all tubes. As factor VIII inhibitors are time and temperature dependent, we now incubate all of our patient and calibrator tubes at 36 degrees Celsius for 2 hours. Following our 2-hour incubation, we give our samples a good mix and then we load them onto our automated analyzer and process both our patient samples and our calibrator for a 1-stage factor VIII assay. Once we have our raw factor VIII results, we need to calculate our residual factor VIII. Residual factor VIII is essentially how much factor VIII is remaining in each dilution after the 2-hour incubation period, if we assume our calibrator value is 100% factor VIII. Using the calculation shown, we can calculate the residual factor VIII for each dilution. To calculate our Bethesda titer, we need to select the residual factor VIII closest to 50%, as this has been shown to improve accuracy of titer results, especially in patients with type 2 kinetics. In reality, you are unlikely to have a result of exactly 50%. Therefore, the result closest to 50%, which lies between 30 to 70%, is acceptable. We have chosen our residual factor VIII closest to 50%, which is 46.67%. To calculate the Bethesda titer, we have two options. The first is to use the calculation shown here, whereby we use our residual factor VIII of 46.67 and our dilution factor from which this result was obtained, which is 32. We input these into the calculation, and that gives us our Bethesda titer of 35.2 Bethesda units. Our second option is to read our results from the graph the equation comes from. In our example, I read our residual factor VIII rounded up to 47% off of the y-axis, which gives me a Bethesda unit from the x-axis of approximately 1.1. I then multiply 1.1 by my dilution factor of 32 to give me a titer of 35.2 Bethesda units. Now we have our Bethesda result, it is important that this is communicated urgently to a haematology clinician so that treatment can be started without delay. As mentioned at the beginning, this is one of many ways of performing a Bethesda assay, and slight variations will occur between laboratories. I hope you found this informative, and thank you for listening.